So what were the numbers up there?
Oh, like one. I know 101 and 103 are two numbers.
What is this?
There's also 97 and
Okay, let's go. Maybe we can leave a little early. Number 99. Say what, girlfriend? E to the x equals 10? Okay. If it's in exponential form, change it to logarithmic form.
I think it's 3x. Yeah.
What? Number 99?
Yeah.
Same thing. Okay, change it to log. Log base E of 10 equals 3x, right? So e to the 3x equals 10. But you have to solve for x, so just divide by 3. So x equal log base e of 10 over 3. But log base e, we don't write log base e, right? What do we write?
Log 10.
Natural log 10 over 3. Remember, natural log 10 means log base e of 10, but it's just that we don't write it like that. Why is that befuddling? Okay, next. I saw 4 numbers up there.
101.
101. That looks like the same problem except different. E to the 2x plus 5 equal 8. Hey, this looks like the next quiz, which is probably next Tuesday. Look, do the same thing. If it's in exponential form, write it in log form. That's why, okay, that's why we have logarithms, you know, not just so teachers have jobs, so that we can solve equations when the variable is in the exponent. That's what you use logarithms for. So log base e of 8 equals 2x plus 5, right? Because e to the this equal that, which is the same as that. But again, we don't write log base e of 8. What do we write? Natural log 8. And then now easy, subtract 5. And then how do I get rid of this 2? Divide by 2. So you get natural log 8 minus 5 over 2. Can I go 8 minus 5 is 3? Yeah, you can, but that's going to be a minus 5. You can't do that because this goes together. Natural log 8 is a number. It can be punched in on your calculator. It's like, don't tell me! 2.2, 2.1, 2.2. Who has a calculator? I want to see if I still got it. What is natural log 8? 2.2. I'll go with 2.2. Jin? Say what? No, natural log, the ln one. Ln, then 8, and then close parentheses. 2.1, darn it! I lost it. I'm losing it. I apologize. Okay, next. Next. Yeah, it is unacceptable. I have a bad weekend now. Next. Come on. There were 4 numbers up there. Whoever wrote it, gotta remember it. Koyanagi. So we're done with the homework? Okay, then we go on to the next section. Okay, the properties of logarithms. Now, in your book, they list all these properties, but then some of them are just so inane that they don't even need to be mentioned. Like this. Log base b of 1 equals 0. That's a duh, right? Any number to the 0 power is 1, right? So it doesn't matter. I can put any log. Look, what is log base 5 of 1? 5 to the what power equals 1? 0. It doesn't matter what base I put. Log base 7 of 1. What is that equal to? 0, because 7 to the 0 power is 1. And what about natural log 1? E to the what power equals 1? 0. So anytime you have log 1, that's 0. They put that in the book. We don't really need that, do we? No. And what about this? What about log base b of b? B to the what power equals b? 1. What about log base 5 of 5? 5 to the what power is 5? 1. That's listed in there. That's inane. Okay, but now, these are the 3, or there's 4 you gotta know. Here's the first one. Log base b of m plus log, I'm gonna use small m. Log base b of m plus log base b of n is equal to log base b of m times n. Log base b of m minus log base b of n is equal to log base b of m over n. And log base b of m to the nth power is equal to n log base b of m. Well, that's what logarithms are, right? Logarithms allow you to work with the exponents, yeah? So yeah, it kind of reminds you of the exponent rules. Yeah. So these are the 3 you gotta know, and there's one more, but we'll discuss that later. So this is the kind of problems you're gonna have to know. You just have to get used to these rules. And this base can be any base now. It can be base 2, base 3, base E, base 10, base 7, it doesn't matter what the base is. So what if you have log base, I got a good problem. Log base, wait, I got a better problem. Log base 6 of 4 plus log base 6 of 9. This would be a good problem for the quiz. Simplify this. Basically, that's what you're doing tonight, simplify it. Now, this one looks like which of the properties? A, B, or C? It looks like A. So when you're adding logarithms, you can combine this into a single logarithm. So how do you do it? If you follow that rule, you multiply the 2 thingies. So that's log base 6 of 36. Okay, so you do this on next week's quiz, you get 1 point. You want the other point, you gotta simplify that. Is this a number you're supposed to know? 6 to the what power equals 36? 2. See, let's simplify it to 2. This is like today's quiz, right? Yeah. So when you see a plus sign there, you multiply the 2 arguments. When you see a minus sign, you divide the argument. Okay, what about this? Log base 3 of 7 minus, no, moose bread. Log base 3 of 18 minus log base 3 of 2. Simplify that. Well, it looks like one of these 3. Which one? The middle one. So when you subtract logarithms, you can make just one single logarithm. And what do you do with the 2 arguments? You divide them. 18 divided by 2. Well, what is 18 over 2? So this is the same thing as log base 3 of 9. And is that a number I know?
2.
Yep. 3 to the what power equals 9. Woo! Hey, this is pretty simple. What about log, this is not really simplifying it, but log base, log base 3 of, no, that's not, come on, 4 to the 2nd power then. This is not really simplifying it, but whenever you have a power on, now notice that it's not the whole thing squared, it's just that part is squared. Okay, so when just the argument is squared over here, or when it raised to a power, what can you do with the power? Following this 3rd one, what do you do? It's like you put it in the front. So whenever you have log base something of something to a power, this power can be put in the front. Like that. And then there's not, you can't, because 3 to the what power is 4, nothing nice here. You can't really do anything with that. Okay, but these are your 3 properties of logarithms. And you have to be able to go back and forth either way now. The examples I gave you, you start with this and you go to that, but you also have to be given that and go to that, but that's kind of dumb, right? Like here, true or false? Log of 6 is equal to log 3 plus log 2. True or false? Yeah, that's true. That's the first one, yeah. But do not do this. Log base of 4 plus log base 2. Is that equal to log 6? No. Because using your rules, this will combine together to just get log of 4 times 2, which is 8. And log 8 is not equal to log 6. So this one is not true.
And the first two equations would of these always be the same.
Yeah, they have to be the same. So if it's log base 6, then it's got to be log base 6 here. Yeah, these two bases have to be the same. Otherwise, you cannot use these rules. Okay, and then the last thing you got to know is the change of base formula. Change of base. Because when you work with a logarithm, you can have any base. But if you look on your calculator, which logarithms do you have on your calculator? You guys even notice? Try look. Everybody look. Because you guys got to be able to punch this in on
We
your
have
calculator.
a regular log for the element.
Exactly. So the only two logs you have on your calculator are log base 10 and natural log, which is log base e. So what if you have this number? What if I ask you to say, what is this number? Log base 3 of 100. Punch this in on your calculator. Cannot, because you don't have a log base 3 button on your calculator. So what you have to do is you have to change the base. So this is it right here. Log base b of a. So if you have any logarithm, you can change it to any base you want. Log base c of a all over log base c of b. This is the change of base formula. And it's pretty easy to remember because look, no matter what, you can pick any base you want here, but look, the top number goes on the top and the bottom number goes on the bottom. So easy. Okay, now before I show you how to get this on your calculator, can you think of what is this number equal to? Is it 1 point something, 2 point something, 3 point something, what? Because what does this mean? This means 3 to the what power equals 100. Well, we know that 3 to the third power is 27. We know 3 to the fourth power is 81. And we know that 3 to the fifth power is 243. So what do you think this number is? 4 point something, right? If 3 to the fourth power is 81, that's 100 now. Then shouldn't the answer be 4 point something? But that's not good enough. I mean, if you do it in your head, you know the answer is going to be 4 point something. But when you use a calculator, you got to be able to give it to 3 decimal places, right? So we use the change of base formula because your calculator only has base 10 and base e on it. Okay? So which one do you want to do? The log base 10 or the log base e? Doesn't matter. Pick one. Okay, good choice, because if you said base 10, I would have said wrong. But you can do it. But see, the reason why we have base 10 is because humans have 10 fingers, right? That's how we like to count. But when you go on to calculus and higher, that number e is going to be super important. So I would suggest to you that if you can pick a logarithm, you always do natural log, because everything in calculus is natural log. So using this property here, this is equal to natural log 100 over natural log 3. You see why? Because natural log means log base e, except we just don't write log base e. But the top number goes on the top and the bottom number goes on the bottom. See? Top number on the top, bottom on the bottom. Can I cancel out the ln's? Don't you dare. These, you cannot cancel ln. It's not ln times 100. It's natural log of 100. Okay, now try punch this in on your calculator. Natural log 100 divided by natural log 3, and the answer should be 4 point something, like we said from the beginning.
5.1.
So 4.511? We concur? Park, just
I have 4.19.
4.19? What's going on?
That's what I got.
What 3 places? 19 what?
192.
Okay, now do we concur? Just gotta punch it. Now, some of you say, Mr. Parker, I don't care what you say. I don't like natural logarithms. I'd rather do the base 10, the common log. Well, do that then. Then log 100 over log 3. Try punch that in. I bet you get the same thing. I bet you all the money in my wallet. Park, how can you be on Team Korea if you don't bring your calculator?
Yep.
I'm a fail to Koreans.
can you see, when you use the change of base formula, you can change it to any base you want. It doesn't have to be E or base 10. You could change it to base 7 if you want, but then there's no log base 7 on your calculator. You know what I'm saying?
Can I drink in Korea now?
Maybe. Okay, let's just do one more then, and then we'll go home.
Yeah.
Log base 2 of 1,000. Okay, tell me, what is this number? Wait, don't use your calculator yet. What is this number?
100.
Is it 1 point something, 2
Oh.
point something? Come on, you gotta get used to numbers. Okay, what is something we know? 2 to the 4th is
16.
2 to the 5th, 32. Just come on, you're supposed to have these memorized. 64, 2 to the 7, 128, 2 to the 8. Just keep multiplying by 2. 256, 2 to the 9th is 512, 2 to the 10th is 1024. I would highly recommend you memorize that because it comes up a lot.
That's about 9.
Yeah, so it's 9 point something. So what would your guess be?
9.8.
Is it closer to 10 or closer to 9?
It's closer to 10.
Yeah, because 1,000 is closer to this than that, right? So 2.8,
Yeah.
no, I mean 10.8, no, what did you say?
9.8.
9.8, that would be a good guess. Okay, now do that on your calculator. So you have to change the base. So this is the same thing as natural log of 1,000 over natural log of 2.
9.9.
Give me 3 places.
966.
Oh, so 9.8 wasn't good enough.
I was going to go with 9.9, but I didn't want to get overly excited.
So what you have to do on tonight's homework is get used to these properties of logarithms. I believe we're spending 2 days on it. Is that what it says on the assignment sheet? Yeah. Okay, let's go home.